Hi, this is a lecture on probability. In everyday life, we often talk about things being probable or the chances of things happening. It turns out that there is a mathematical way to express this chance, or as we call it in mathematics, probability. We first look at what is called empirical probability. And for the scope of this course, we will be studying only empirical probability. And so therefore we'll refer to empirical probability as probability itself. So empirical probability, or probability in this case, is defined as probability of event E is equal to number of trials in which the event has happened upon the number of total trials. Say there is a happening or a trial in which numerous events are possible, and you want to discuss the possibility, or you want to discuss in strict mathematical sense the empirical probability of, say, event A. And if in that trial event A, B and C are, say, possible, we will look at the number of times the trial was conducted and in the number of trials in which event A happened. And so the number of times in which event A happened will go here, and the total number of trials will be the denominator, and the ratio will give us the empirical probability. The idea will be very much clear with an example. So we start off with a very basic example. Say a coin was flipped 500 times and the following data was recorded. Heads was seen 239 times and tails was seen 261 times. So say we want to find out the probability of getting heads. That is probability of getting heads. So we'll define probability of getting heads as P of H. Let's call the event H itself is equal to, let's look at the formula, number of trials in which the event happened. Now this is the number of times in which the event of head coming up happened, and so therefore the numerator will be 239, and this will be divided by the total number of trials, that is total number of times the coin was flipped in this case. So that is 239 by 500, which turns out to be 0.478. So 0.478 is the probability of getting heads, or the empirical probability of getting heads. Now let's look at probability of getting tails. That is P of L is equal to number of times the event happened, number of trials in which the event happened, that is 261, and the total number of trials, which is again 500, which is equal to 0.522. And so therefore we have the probability of getting tails, the empirical probability of getting tails. Next we look at another problem, which is 2000 families were surveyed and the following data was recorded. Number of cars in the family 2, 1 or 0, and the number of families with the corresponding number of cars is 354, which had 2 cars in the family, 712 had 1 car in the family, and 934 had no cars in the family. This data obviously is not from a real survey. It's been randomly generated for the purpose of setting a proximate set. So let's say we want to discuss let's define an event as family having 1 car. So if you want to look at the probability of a family having one car, we'll discuss the probability of event E, which will be given by the number of families which have one car, that is 712, upon the total number of families surveyed, and that is 2000. And so you get 0.356. And similarly, if you want to find out, say, the probability of family having no car, let's call it, say, event F. So the probability of event F is equal to the number of families having no car, that is 934, divided by the total number of families surveyed, that is 2000, which in turn comes out to be 0.467. And similarly, you can find out the probability of a family having two cars. Let's say you want to find out, let's define an event, say G, family has at least one car. So please take note that event G will not be equivalent to event E, because both these families would constitute the event G, that is having at least one car, because having two cars would also mean that you have at least one car. And so therefore you write the probability of event G, that is having at least one car, as the number of families having at least one car, that is the sum of the number of families having two cars as well as the number of families having one car. So that will be 354 plus 712 upon the total number of families surveyed. So that is 2000, which equals to 0.533. So this is pretty much all there is to say pertaining to probability insofar as the scope of the course is concerned. Obviously, the calculation of probability gets much more involved, and that will be discussed in higher classes. Some additional comment that I wish to make about probability is that the probability of an event is always between 0 to 1, because basically if you look at the definition itself, it says the number of trials in which the event happened and the total number of trials. Now there can never be a case in which the total number of trials in which the number of trials in which the event happened is greater than the total number of trials itself, because that would obviously be absurd. So therefore this number, that is P, is either equal to 1 or less than 1 in all cases. It is equal to 1 in which all the trials led to the event that we are discussing. Also, this can not be less than 0, because the number of trials cannot, obviously, number of trials in which the event happened cannot be really negative, and also the total number of trials cannot be negative. So therefore the probability of an event happening is greater than 0. It can be equal to 0 in the case that the event of discussion never really happened in the trial. So therefore the probability can be 0, and hence the probability of an event is from 0 to 1. This is pretty much all we had to say about probability. The golden formula for probability remains this, and this is all for now. Thank you.